Hello, welcome back to your virtual Algebra 1B class. Woo! Okay, on page 82, yesterday you did some whiteboard practice on writing the equation of a parabola. Page 83, we're going to complete the right side of that paper I posted on Tuesday, which we put it in our pocket page. So let's go to our pocket page and grab Projectile Motion. I am going to use a couple of highlighters just to point a couple of things out. So if you want to grab your highlighters, go ahead and do that. You show you title and number, page 83, Projectile Motion. Same title right here. Yay, word problems. Our favorite thing in the world. But no, really, don't let these word problems intimidate you. It has a whole lot of words in it that aren't even really that necessary. As long as you can find the equation in the problem, I'm gonna say you're all right. So find the equation, figure out what it's asking for, and then just do the math. So this first scenario, first of all, projectile motion. That's what happens when you throw a football or if you kick a soccer ball. Anytime you throw or launch something, it makes a parabola. We call it parabolic flight. So projectile motion is just basically word problems using quadratic equations because quadratics make parabolas. So, number one, a soccer ball is kicked from the ground with an initial velocity of 90 feet per second. So you're going to see these words, initial velocity, kicked from the ground, because it is asking you, well, it's more so telling you that everything went right in this scenario. So it's for those nitpicky, sciencey people that are like, oh, well, was it on the ground or was it hovering on a table or something like that? So it's just really trying to be very specific that we started at 0, we started on the ground, and the initial velocity, the first speed it had, was 90 feet per second. So if we don't know what velocity means, it basically just means speed or how fast it's going. Starting from the ground, they're basically telling us that we started at 0. So if you're thinking about a graph, if this was a graph, it started at 0. Whereas this problem was all the way up here on the graph. But we're thinking about a soccer ball. Soccer ball on the ground was kicked and then had a velocity of 90 feet per second. So the equation h equals negative 16t squared, which is a very common number used for these word problems for sciencey purposes. When you go to physics and take that class, you'll learn more about why this number is used so often. So negative 16t squared plus 90t. So they're using t's instead of x's because t is representing the time, okay? H is representing height. I think maybe I was typing too fast and I forgot to put height. So the equation h equals gives you the height of the ball after a certain amount of seconds. Okay, so number one has two parts, A and B, which is going to be similar to 2 and 3. So the first thing we're going to do on number one is find the maximum. Ugh, this ink does not like to be highlighted. Which is all you have to do on number 2. So number 2, you're going to do the same way, same as 1A. And then number 3 is going to be the same as 1B. It's asking how long does it take to reach the ground, and number 3 is also asking that same question. So when you go to do number 3, go back and look at 1b. It's the same as 1b. Okay, so I'm going to do both of these types of questions in number 1, and then you guys will do 2 and 3. I will give you until Monday at midnight to submit that, and then Tuesday I will make more practice problems based off of what everyone's work is looking like, what you need more practice on. Okay, so back to our scenario, number 1. We have a soccer ball, it was kicked, they gave us this equation to represent the soccer ball's travels. So find the maximum height of the ball. And the maximum is the vertex, which we did this way back on page 68 and 69. So if you need review on how you find the vertex, go back and look at those pages. Here, I'll show you real quick. So page 68 was this really long worksheet. Down at the very bottom, we got started on solving for the vertex. So first, finding the axis of symmetry using this equation, opposite of b over 2a, to figure out x was equal to -4. And then after you figure out what x is, you plug it back in to figure out the value of y. And then it's just PEMDAS from there until you get one number by itself. So we're going to find the vertex, the coordinate points where the soccer ball is at the maximum. Maximum is a vertex. So they use H and T instead of X and Y, and that's all right. We just have to remember that the first step, we're figuring out what T is equal to, which is the opposite of B over 2A. So using this equation, we know that A is a number in front of T squared, so A is -16. B is a number in front of T, so B is +90. So the opposite of B is going to be -90 over 2 times A, which is -16. Remember, you only change B, you keep A, whatever it is. So this is really -90 over -32. So that is going to be a fraction. Well, it is a fraction. Remember, fractions represent division. So you are really just dividing -90 divided by -32. And you are going to get a decimal. That is okay. So let's round that decimal to 2 decimal places. So the nearest hundredth, 2.81. Since there's a 2 next to the 1, it's going to stay a 1. We want 2 decimal places just so our answer is a little bit more accurate. Instead of doing 2.8, we're going to do 2.81. So now that we know what T is equal to, we have half of the answer. Our answer is going to be the coordinate point 2.81, comma, whatever we get for H after we plug it in. My 2 kind of took over the decimal. Okay, so we're going to take our equation, -16, and we're going to take T out and plug in 2.81. Now to figure out h, we need to do PEMDAS. So we have negative 16 times 2.81 squared. 2.81 squared is going to give us 7.9. Let's actually practice just typing directly in the calculator. So using the EPISA approved calculator, we can do 2.81 squared times 16 negative. Okay, so that's going to give us that long number. I'll show you step by step. So we have 7.896 here, plus 90 times 2.81. So now we can multiply both of these numbers. It's negative 16 times this, 90 times that, and then add it together. So when we multiply negative 16, we get negative 126.34 plus 90 times 2.81, 252.9. Last step is to add those together. So 252.9 plus 126. Press the decimal too soon. 52.9 plus 126.34 negative equals 126.56. So that will be the y value, 126.56. So this will be the answer. The maximum point is this. So at 2.81 seconds, it's at 126.56 feet. So I suppose technically if they want the maximum height, it is this number. Alright, I know that's kind of a lot of decimals, but just try to keep track of your PEMDAS, your negatives, and just write as many decimals as you can. If you can write 3, that would be good. Rounding to 2 or 3 decimal places will keep your answers the most accurate. Okay, second question. How many seconds will it take for the ball to reach the ground? So they're asking us when the height is 0. Now, if you think about a graph, the ball starts here at the ground, and it goes on a little ride, and then it hits the ground again. So they're asking us how long will it take for the ball to reach the ground? So thinking about the graph, the ground is the x-axis. So we want to figure out this x-intercept. So we are going to use the quadratic formula. Remember, we've done multiple different ways to figure out the x-intercepts. We factor, equal the factors to 0, and then we use the quadratic formula, which works on any quadratic equation. So we're going to use that formula. Opposite of b plus or minus square root b squared minus 4ac all over 2a. So let's identify a, b, and c. We already said that a is negative 16, b is 90, c, there's nothing here. So what do you think we're going to put for c? 0. Very good. All right, so we are going to plug those numbers in. Opposite of b, positive 16 plus or minus square root b. Oh man, I put 16. That's a. Wrong, red alert. Not right. A is 16, B is 90. Come on now. B, opposite of B, opposite of positive 90, negative 90. Plus or minus square root B squared, 90 squared, minus 4 times A times C is 0. So if we have 4 times 16 times 0, this whole thing's going to go away. It's just 0. This makes 0. Okay, I'm getting ahead of myself. All over 2a, so 2 times negative 16. All right, so we have negative 90 plus or minus the square root. We just said these three numbers multiplied together is 0, but we still have 90 squared under here. So 90 squared, 90 squared is 8,100. All over 2 times negative 16, negative 32. All right, so at this point, you can go ahead and break it apart. You can do the plus and the minus and practice typing it in your calculator. And let's write down our answers. We're going to get 2 answers because we're going to add and we're going to subtract. All right, so we have to hit 90, negative, plus 8,100 square root equals, okay, that gave us 0, divided by 32 negative is still 0. So one of these answers is 0 because that is one of our x-intercepts. That's where the ball started. Now we need to figure out where the ball ended. How many seconds did it take for the ball to reach the ground? So instead of adding, let's try subtracting. 90 negative minus 8,100 square root equals, okay, that gave us negative 180 divided by 32 negative equals. Okay, so we get 5.625. That is a positive value, so it makes sense. We have to have positive time. So this would be the answer. It took 5.625 seconds for the ball to hit the ground. Alright, so that is how you'll do number 2 and number 3. Number 2, remember you're only doing this. Number 3, you are only doing that. If you want to practice both ways, you can. Feel free. And I will give you until Monday at midnight. I'll host a Zoom on Monday to answer any of your questions. Be sure you join us on Zoom if you have questions, if you want help working out any of the problems together. Okay, good job making it through this video. See you soon.